Hi, I'm Josh, G3MOT, and I'd just like to introduce you to a new product I've been working on. It's called the SuperSig. It is a two-element Yagi, which changes from 20 meters down to 4 meters, and it's all contained in this fine little bag. So this is specifically designed for SOTA, POTA, BOTA, any of these portable operations. And if you're like me and can't have a tower up full time, I just put this out, work contests with it, or you know, if there's some DX on, I will just pop it up, and off we go. So it's worked wonders for me. So I thought I should make it available to everybody, really. So anyway, what's in the bag? Okay, we have the boom. So we've got one half of the boom section here with a common mode choke on it. The hub here is where the driven elements for these the whips will go. We have the other half of the boom here, again with a hub on it for the whips to go into. We have the joiner to join the booms, each side of the boom together. We have a mast plate, so you can pop it onto your mast. And we have the four 5.6 meter telescopic whips, which are actually the crux of this thing. They're fantastic. We also have a little joiner here, which joins the directors together electrically. And we have the hardware, which there isn't very much. I've done my best to make this as easy to put up in the field as possible and as lightweight as possible. And we have a little here hex nut driver here just to help us get some tension on these wing nuts when you bolt them together. So I just want to show you how the boom goes together. Then we get on measuring the whips, and then we do some testing, and then we get it up in the air and actually make some contacts. So first thing's really easy. You get the boom, you got the joiner here. You can just slide these in, marry up the holes together, locate the holes. We get one of these wing nuts and bolts in either side. You've got a washer each side of it, so pop that in here. This goes straight through here like that, and we'll just do it up just finger tight for the time being until we get everything attached, and then we can go around and tighten everything. So then you just pop the next section in. It's dead easy. Oh, make sure you've got these both facing upwards, because the amounts of times I've put this in and it has been like that way round, and then you have to take it all apart again. So just from experience, just a thing to look out for. Make sure both of those hubs are pointing up. So just pop this one in, same as last time. You've got a washer in one side, washer in the other, and your wing nut on top. Give that a bit of a turn. Like I said, doesn't need to be tight. Then we get the mast plate that needs to go on. I did do a version where it hasn't got both of these. It's just got one clamp that goes through the middle. Fine if you're using aluminium a mast, but if you're using fiberglass or something quite small, this works really well on fiberglass. So I recommend you get one of these if you're using it on a fiberglass pole. It's a bit less aggressive, and it won't damage your pole. So these pop out. Same again, you can just pop this straight through. So make sure all the wing nuts go through onto the same side. Don't put this one on that side like that. You want all the nuts on one side of the boom. Get your washers on, the wing nut on. Just give it a spin. And there we go. And then we can use this little hex driver just to help us get some tension on it, so you can pop it on its end. Just pop that in there, and you can just get some tension on these now. Do these first, make sure it's all in nice and tight. There we go. And that is the boom constructed. So next I'll show you how we can, which is probably actually the trickiest part of this whole thing, is how we get the whips to the correct lengths. You only need to do it once and mark them up, but the first time, well, it's not tricky, it's just a bit time consuming. But once you've done it once and you've marked the whips with the marks on them, you know exactly where they are. You can just pop them out, pop them on the boom, on the hubs, and off you go. Okay, now I want to show you how to get the whips measured out for the correct length for the frequency you want to use. I'm going to choose 10 meters today. It's a bit of sporadic here around, so we'll see what that's like. So I know you will get a chart actually in the bag which has all the lengths for each element for the directors and for the driven elements. They're all written down. I've done exhaustive measuring on this, and they're the best I can get them to work for me. You might want to change them a little bit depending on height of your antenna, location, etc. But these numbers will get you pretty much in the ballpark of where you need to be. So this process you only need to go and do once. So first of all, this is quite important because I've made this mistake lots of times. Grab the top of the whip when you're extending it, and make sure you grab right underneath the one below and pull this right out. And make sure you do that with every single one, because I've made the mistake of thinking it's been pulled out to the right length, and it hasn't. And I've gone back in the shack and the SWR has been all over the place, and I've been scratching my head and I've taken it down, and I've suddenly found out that this element is like a whole section shorter than it should be. So anyway, you live and learn, as they say. So we'll get this out. This needs to be what's 267 centimeters long for 10 meters. So we'll pop this out. I reckon that's probably maybe a bit too big. And sorry you can't see all of this, but this is the best way I've found to do it. It's just lay your tape measure down, lay the whips along, make sure you measure it from the end here, from this flange here, not from the end of the thread, just from this flange here. It shouldn't make too much difference anyway, especially when you go up to 20 meters. But at the higher frequency bands, a tiny bit of measurement makes quite a bit of difference to your resonance point. So let's have a look. What are we up to here? We are up to 240, so we need to be 267, so we need a little bit more out on this one. So let's pop it out. I reckon, ooh, there we go. So let's have a look. Yeah, that looks about right. Let's have a look. Make sure we're pretty spot on here. That's 267. It's a miracle. So first of all, once you got the right length, just get your Sharpie, there'll be one in the bag, and just put a little nick just on the end of the element here where it goes into the next part of the telescopic whip, just here. What we'll do is, when we got this all set up and we're really happy with the SWR, we'll make a much bigger mark around here, and you can put a 10 on it or something like that for 10 meters, just so you do. And that's all you have to do. So this one's done. That's all you have to do. What I'll do is I'll go away, I'll measure out the others, and then we'll get them attached to the boom. I'm now just going to show you how we get the whips onto the hubs, get them up, and we can do a bit of testing to see what the SWR is like and see how it performs. So first job, we'll get the whips on. So you just locate these, use two hands, just take the weight off so they go into the threads nicely. They sort of meet up really well, and we can put these in until you got about a mil towards the end, because what we want to do is we want to slide one end of the fork for the jumper across these just in the end of the directors here. So we pop that in. I'll try and show a close-up of this. I apologise for my very shonky old tripod. It's the best I got at the moment, but it seems to work, and it's great for setting these up for the first time instead of having to climb up my ladders and up the beam and stuff like that. So it works quite well for that. So that's one of them on. Very simple. You don't need to over tighten these. That's the last thing you really want to do. Don't use any grips on them or anything like that. It doesn't need to be that tight, and if you, to be honest, if you use grips on it, you destroy it. So they just need to be done up hand tight. You can put a good turn on it, but that's all it needs. It doesn't need to be really tight, and these are in absolutely solid. So same for the driven elements. Pop one in one side. Again, taking the weight off, and it will locate itself really. It's the threads are fantastic, so it will locate really easily. And the other one, yeah, straight in. And again, leaving a bit of gap, then we can pop in the connectors for the that go to the choke. And again, just hand tight. Doesn't need to be tight at all. So obviously it needs not to be able to unscrew, but it doesn't need massive amounts of attention on those. Okay, so then we can start. I've already marked these up, so I know pretty much where 10 meters is, so we can start popping them out. Same as we did before, just making sure, yep, that's it. Now we can get going. They're all good. So pop these up to here. Seeing the mark for the first time can be a little tricky, but it's only a small one. But there it is. Got it here. It's 267. Same for this side. Now the directors are about 5% shorter. What you can do, you could use them as reflectors and make them 5% longer. I found personally for me, this works way better with using this end as a director. So when you're actually when you're wanting to contact somebody, this is going to be the direction that you want to point the beam in. If it was a reflector, you want it the other way. It'd be going this way, but these would be slightly longer. So let's pop these out. Yep, that's good. That's all out. It's great. There we go. There we go. Let's be getting close. There we go. There's the mark. And this one. We're done. And there's the mark here. Right now, that's essentially it for putting up the whips. We just need to connect up the coax now. I'll go and get the Nano VNA. Hope we'll be able to see it out here. If not, I'll just put the plot on the computer downstairs. But that's essentially it. Okay, I've got the Nano VNA hooked up. It looks really good. We got 1.16 to 1 at 28.48, so great for sideband. Might want to make these a little bit longer if you're going to the driven elements a little bit longer if you're going to use CW down the other end or FD8. But to be honest, it's a really flat line. I've tried to put this into the camera, but it doesn't work. So what I'll do is I'll put it on the computer downstairs, and I'll put this plot into the video so you can see it properly there. Okay, we're in the shack now with the plot from the Nano VNA that we couldn't see outside. So anyway, this gives you a pretty good idea of where we are, and yeah, the frequency has the dip has dropped a little bit down to 28.5, but I kind of expected that with the height. But if you could look over at the marker 1, marker 2, marker 3, it looks pretty good. We got SWR of virtually 1-to-1 really on 28.46 4960. Let's move it, see what we can get. There we go. Let's move the marker to 28460. Yeah, 1.80. So that's pretty, I mean, you're not going to get much better than that on any antenna. Impedance pretty much spot on, 48 ohms. So yeah, this is how it looks. It's pretty good. It's quite wide banded as well. You get pretty reasonable SWR, pretty all the way through the 10-meter band there, which is quite impressive. But the impedances do start to change. So like I said before, if you're going to use FT8, you might want to lengthen the driver a bit so we get the dip further down towards 28074, which is where you really want to be. But anyway, I just thought I'd show you this. Okay, so we've actually got the antenna on the mast now, and we're going to see how it performs. It's sort of pointing into the middle of Europe, sort of southeast really from here at the moment. So let's go and check it. Okay, we got a Yankee Lima station here. Yankee Lima 2 Lima Whiskey towards F10. Germany 3 Mike Oscar Tango. Oscar Tango station, Mike Oscar Tango. Yeah, very good evening to you. It's Germany 3 Mike Oscar Tango. Roger. Sure, good. Copy now. Just good evening, Mike. Sorry, Germany 3 Mike Oscar Tango. Yankee Lima 2 Lima Whiskey. Beacon 8 to Operator Victor. Over. Yeah, Roger, Victor. No problem at all. You're picking 5757 with me. But a great signal, a Q5 copy, a little bit of QS Baker on the band, but all good. Just testing out a little 2-element beam I've got going, heading into your direction. So it seems to be working really well tonight. The QTH here is the city of Nottingham, and the name, if you didn't get it, is Josh, Japan Oscar Sierra Hotel. So Victor, pleasure to meet you again. I see we've worked before. I can't tell exactly what band it was, but I've seen we worked before, so great to work you again. Yankee Lima 2, Lima Whiskey, Golf 3, Mike Oscar Tango. Roger.
Copy. Good copy, Jeff. Thanks for the call. Best wishes and good evening to you. Germany 3, Mike Oscar Tango, Yankee Lima 2, Lima Whiskey. See you again. Good luck.
Yeah, cheers, Victor. All the best, 73, and bye-bye. Okay, so that was cool. That was on the SuperSig, and this is now this is signal on my MFED half-wave, which is a pretty good antenna. But he's now 55 tops on this, I think. Let's have a look. There we go. Pretty much quite hard to copy. I'll change it back to the SuperSig. Just gonna have to wait for it to come back. There you go. That's MFED half-wave again. I'm back on the SuperSig. So you're kind of getting a couple of S points gain on top of the MFED half-wave. So happy with that.